Hello and happy Monday. Today is Monday, March 2nd, 2015. Today is a red day. Please follow along with the video to complete your packet. Anything that you do not get done will be homework. The video is on Blackboard. So what this means, like even today in class, if you don't get through the video, you need to go home, watch the rest of the video for homework, and complete any other pages, and then we'll check them tomorrow. So the quieter we are and the harder working, the less you'll have to do for homework. All right, let's get started. All right, so the side congruence theorem states that if three sides of one triangle are congruent to the corresponding sides of another, then the triangles are congruent. So yesterday, well, Friday, today, and tomorrow, we're studying how line segments are congruent and then using that to prove triangles are congruent. And there are three theorems. So if you look on the board, the objective today says use triangle congruence. Our three theorems that we have are side, 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 which we're going to talk about in just a second. Then we have side, angle, side, which we'll talk about in about 3 pages. And then tomorrow we'll talk about angle, side, angle. So if triangles have these three things, then we can prove they're congruent. So our directions here say use the SSS, side, 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 which means side, 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 to determine if the two triangles are congruent. So you can see they've been rotated. So if we want to find out if they are congruent, we'll have to compare the sides. That's why we already practiced Pythagorean theorem. So this is the short side, and this is the short side. So we want to see if those two are the same. Does MA equal NR? Then we'll want to see, does MQ equal NP? And then we know Pythagorean theorem, so we can use those two lengths to solve for C. A squared plus B squared is C squared, and see if the pink or the C, the hypotenuse, is the same. If all three sides, if you know that corresponding parts of a triangle have equal measures, then they're congruent. And since we're using side, 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 this is called SSS theorem. Okay, so let's measure the different sides here. A squared plus B squared is C squared. A, the short side, is 1, 2, 3, 4, 5. And then this short side, NR, 1, 2, 3, 4, 5. So let's label those. Go ahead and figure out how long B is. So go ahead and do this one. Okay, remember to pause anytime you need to work on something or catch up. But we have a 5 by 7. So if we plug in for A and for B, we will have A squared, 5 squared, plus B squared, 7 squared, equals C squared. So go ahead and pause it and press play. When you're done, I want you to solve for C. And let's round to the nearest 10. Okay, so we should get approximately 8.6. So now it says right here, be sure to write a final statement. Okay, so let's do the different steps. The lengths of the different sides are equal. So QA is equal to PR, so the hypotenuse equal to hypotenuse. So we need this side equals this side. We need AM equals RN. That was the side that was 5. And then we need MQ equals NP. And that was the side that was 7. So we had the 8.6 side. Please write all this down. The 5 side and the 7 side. And if we say this, each side corresponds with the side-side congruence theorem, we can say triangle PRN and triangle QAM are congruent. Another way we could have written this was triangle PRN is congruent, remember this symbol from last week, to triangle QAM by the side congruence theorem. So pause this and make sure you get all of this written down. Okay, let's move on. If the lengths of two sides and the measure of an included angle of a triangle are known, do you think it's enough to draw a congruent triangle? And an included triangle is the angle formed by two sides of a triangle. So we're going to explore this. It does want you to use a straight edge and a protractor, but I want you just to do your best guesstimate and follow along with me. That way we can save a little bit of time. So go ahead and pause this, try to sketch this triangle to the best of your ability. Do notice that the angle here is bigger than an L, so it's bigger than 90 degrees. So when you think of that, try to draw something a little bigger, and then notice BC is longer than AB. Obviously, you would have semi-straight lines. So go ahead and sketch that for me. Okay, so down below it wants to know the side lengths of AB and BC. So let's say AB is about 2 inches and BC is about 3 inches. Now it wants us to find the measurement of angle B. All right, so if I put a protractor on my triangle, we will see the measure of angle B, so from here to here, is about 120. So this whole thing is what we're measuring. And it's about 120 degrees. So let's go ahead and write that down. Okay, now it wants us to reuse our parts from B and C. So our 2-inch line, our 3-inch line, and our 120 degrees to re-sketch the figure. So first, you'll start by wanting something that is bigger than 90, remember, so about 120. So draw a little angle, not a little angle, a big angle, obtuse angle, but make it small. The lines are small, so about 120. Then you'll want to extend this side about 2 inches, and you'll want to extend this side about 3 inches, and then you'll make your straight lines. And then label it DEF. Your last step will be to connect the D and the F. So go ahead and sketch your figure, press pause, press play when you're ready. Based on your knowledge about the properties of congruent triangles, what other information is needed to determine if two triangles are congruent? I need to know the measure of the corresponding angles and the length of the corresponding sides to determine if they are congruent. So this is side, angle, side. It's a side, the angle that's in between the two sides that you have, and then the other side. And the way you could do that is to use a protractor to measure the angles and a ruler to measure the side lengths. So we just kind of guesstimated today, but I promise it works. I just didn't want I just wanted to save time by not getting out the protractors and the rulers. Remember, we're doing this chapter in 3 days. Next, so it wants to know, determine if anything else will be needed. Oh, no. Determine the measurements to get any additional. Okay, so yes, the two triangles, the DEF and the ABC that we just sketched, if drawn perfectly, and remember we sketched them, are congruent. So side, angle, side is our second theorem. Remember back here we talked about that we were going to have 3 things and do 2 of them today. So side, angle, side. So let's go ahead and highlight that and talk about that. So we kind of just proved it, that it works. So let's go ahead and pause and take a minute. Please find this side, and then find this side, and here, and here. And then I'm going to tell you that this angle is 90 degrees. That way we don't have to get the protractors out. So go ahead and measure the sides, and know that these angles are 90 degrees. Do that now. So the way that we can use side, angle, side is if we have side, angle, side. So I did a side, 7, and I have a 7. Then I have an angle that's in between the two sides that are touching of 90. Then the other side, you have to have the two sides, the included angle is the angle in between the two sides that you have is 8. And I have that here. So I can say AM and RN are equal. I could say MQ and MP are equal. I can say the angles are equal, M and N. So by side, angle, side, those two triangles are congruent. So you can also say for this last statement, triangle AMQ is congruent to triangle RNP. So if you want to shorten that. Also, I'll show you in a second, we can shorten these. We could do AM is equal to or congruent to RN. But let's get this down, and then let's move on to the next page. This page is all about representing congruence. So slash marks, so down here on this figure, there's slash marks. It's telling you what they mean. They're used to convey congruent lines. So when there's one slash, just like we would have y1 and y2. If there's a single slash and a single slash, those go together. And we should have seen this before, I think. Okay, now these two guys, since there's a double, this goes with this. So that would mean BC is congruent to DE. And look, they told us that right there, and that's the shortcut way to write it. So now let's use that knowledge down below. So this also works for angles. So the two little tally marks, now we have two little arc marks. So we would have, see how this is a double arc here? So I would look for a double arc. And so now I can say angle R is congruent to angle W. Well, I'm trying. And that's given. They showed us that in the picture. The next one is here and here. But we can't just say angle X is equal to angle T, because look, there's two different angles that measure it up, and they're talking about the small angle. So we'll have to say angle WXB or WXT is congruent to RTS. So let's go ahead and do that. Okay, now on the next page is B, and I want you to try B on your own, or with your table or whatever, but I want you to pause it and try it before I give you the answers. So try to match up the segments and say they're congruent, and then try to match up the angles and say those are congruent. Try B, press pause, press play when you're ready. We're getting close to finish. Stay with me for about 5 more minutes. So we have angle TDM congruent to DZC, and then we have TD is congruent to ZD. So this is just like us identifying what the marks mean. Now looking down here, we could go ahead and put some marks in. 10 is equal to 10, so we could match those sides. The 90's marked, so that's good. See, they went ahead and did it. Also, you would know that BC equals BC. This is a reflex. Here, it's the same line. So if this is how tall you are, then, and it's the same line, it's equal to each other. So this, if it was 8 for this triangle, it's also 8 for this triangle. So that's how they did the double mark. So you can see here that the two triangles are congruent by side angle side. We have side angle, the angle that's in between the two sides that we have, and side. Next page. I want you to write the 3 congruent statements. So earlier how I was saying, instead of writing it out as a sentence, one second. Instead of writing it out as a sentence, we'll be able to start writing it using our symbols. So let's go back. We're on page 458. and write AB is congruent to side DC. BC is congruent to CB. And angle ABC is congruent to DBC. And then our final statement we could even add is so triangle ABC is congruent to triangle DBC by SSAS congruence theorem. Okay, so let's get that written. Now 3. We're going to decide if those two triangles are congruent and by what theorem. So we can look here. We have a 6 and a 6. Mark those. We have a 10 and a 10. And that's all we have. But we know Pythagorean theorem. So we could find this. But it's the same line, so we know it's equal to itself. So we don't even have to do Pythagorean since it's the same line. So if you have 3 sides, would you call that side, 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 or would you call that side, angle, side? Side, side, side. And you need to list those out and then say it's congruent by side, side, side. So you have to say the 3 sides that are congruent. Try B on your own. Okay, this one will be side, angle, side. So try B, press pause, press play when you're ready. Try to make up the 3 statements and why it would be side, angle, side. All right, so here we have side, angle. Remember, it has to be the angle in between the 2 sides that you have, and side. And then the rest of the thing is here, but you know this is equal to that piece, and this is equal to that piece. Okay, so make sure you have your 3 pieces, because it's side, 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 angle, side, or tomorrow we're going to do angle, side, angle. So it's always 3 pieces that you need. If maybe they only give you 2, you might have to do Pythagorean theorem. Or maybe it's like this one where it's including the same side. So sometimes you'll have to think, how could I get another piece? All right, so for the homework on the next page, you need to go back and find side, side, side. So on 659 for homework tonight, you need to go back and at once define in your own words. So don't write this whole thing down. Define it in your own words. Once you define in your own words, included angle. So remember we talked about that. So right there, and then side, angle, side. So on page 659 of this packet, you'll write in your own words the vocab. Then on the very last page, you will determine if those triangles, so on the very last page it says triangle JKL congruent to M and P by side, side, side. You'll have to measure them, and they're perfect on the grid. So you'll have the sides. So once you have this page complete, you'll move on to the next page. And you'll want to prove the 2 sides. So you'll measure, 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 just like we did here, but you're measuring them. You'll prove them with Pythagorean theorem like we did in the very beginning. A squared plus B squared equals C squared. So just look back through your packet. And then, instead of listing the sentence out like this, do it how we learned how to, with our statement. So you'll want to say this side is congruent to this side. If they are congruent, maybe they won't be. But you'll want to end up with something like this, and this one would be for the homework. That would be side, side, side if it is congruent. So you'll solve for JK and MN. And then we will check these tomorrow. I hope you have a great Monday. I will be back tomorrow. And have a good night. Remember, anything that you don't finish in class is homework.